Bismillahirrahmanirrahim. This is our first lecture and chapter number 1, that is about vectors and scalars. Our course of MMP have code PHY 301 and we will study it 5 chapter in semester 1. So we started first chapter, vectors, scalars. Now, we have been studying the definition of vector and scalar from our metric, FSE, PSE, and so on. And the basic definition is same. But here we will discuss it on the basis of mathematical tools. In fact, in mathematics, there are certain physical quantities which remains invariant under the rotation of system of coordinate, or you can say that they do not depend upon the orientation of system of coordinate. Such type of quantities are said to be scalars. And there are certain quantities which changes under the rotation of system of coordinate, or we can say that they depends upon the orientation of system of coordinate. Such type of quantities are said to be vectors. This is the main abstract of this slide which you will read. This is the main abstract of the whole story which is written in this page. So this definition of vectors is in certain words the physical quantities which follows the rotation of system of coordinate, rule of law of rotation of system of coordinate. Those are vectors which remains invariant, which are independent of orientation of system of coordinate. They are scalars. So this is new definition of mathematics which we will study, which we have to go through and have to derive the law of transformation of system of coordinate. This is what I said, the mathematical definition. We describe our physical world by mathematics, but it and any physical prediction we may make must be independent of our mathematical conventions. It doesn't depend upon mathematical convention. In our specific case, we assume that space is isotropic. Now, isotropic means there is no preferred direction. For example, if we have a glass slab whose refractive index is uniform, then the light have uh, no preferred direction. It can move anywhere within the glass. But if we have a specific refractive index, then the behavior of the light will be different in that glass slab. So when there is no preferred direction, it will be scalar. If there is a preferred direction for the movement, for the choice of our coordinate system, it will make vectors. Now this is law of transformation of coordinates. Here you can say that we have two-dimensional system, x and y. We have a point P having coordinates x, y, x on x-axis, y on y-axis. Now when we rotate this system of coordinate at a certain angle phi, we get new coordinate system x prime and y prime. So these x prime and y prime are related with x and y and are discussed with the help of these two equations. which I have already uploaded on my YouTube channel. You can see this figure and how this figure and these equations um, come to be existence. It is shown there in detail. Now x prime is equal to x cos of phi plus y sin of phi. Y prime equals minus x sin phi plus y cosine phi. Now if we have vector coordinates ax, ay before rotation of system of coordinate a prime x, a prime y after rotation of system of coordinates, then a prime x, ay prime x are correlated with ax, ay with the help of these equations. These equations have similar meanings x in the case of x prime and y prime. Similarly, if we have any other particle, any other physical quantity denoted by v, its component will be Vx, Vy before rotation of system of coordinate, Vx prime, Vy prime after rotation of system of coordinates, and they will be correlated with these two equations. So this is law of transformation of system of coordinate in two-dimensional system. If we have three or four or more dimensions, then we cannot use these conventional coordinate system x and y. Now we replace x with x1 and y with x2. We will get x1 prime, x2 prime, and x1 and x2 before and after rotation of system of coordinates. Whereas cosine of alpha, sine of alpha, they are denoted by a11, a12, a21, a22, and are known as direction cosines. As we know that the direction cosines are defined as the cosine of angle of any vector point function with x-axis is known as direction cosine. Here it is denoted by a11, and this is the direction cosine of angle between x1 prime and x1. x1 prime and x1, that is phi. Therefore, it is cosine of phi. All these direction cosines are well defined and are denoted by the uh, coefficients a11, a12. For example, if we want to calculate a21, a21 will be the cosine of angle between x2 prime and x1. And now x2 prime and x1 angle is phi plus pi by 2. And phi plus pi by 2, that will comes out to be minus sine of phi. And it is minus sine of phi as in case of as shown in the equations. Now this x prime will become x1 prime and will be equal to a11 x1 plus a12 x2. Similarly, y prime will be replaced by x2 prime equals a21 x1 plus a22 x2. In uh, generalized form, this can be written as xi prime equals summation aij xj, where I varies from 1 to 2 and j also varies from 1 to 2. When you replace I with 1, you will get first equation. When you replace j plus 1, I plus 2, you will get the second equation. And in this way, the law of transformation is completed in terms of direction cosines, that is denoted by aij. For n dimension, the I will be from 1 to n, j will also be 1 to n. Similarly, if we have n dimension and our vector is v having coordinates v1, v2, v3, so on, vn before rotation of system of coordinate and v1 prime, v2 prime, v3 prime, so on, vn prime after rotation of system of coordinates, then prime and unprimed coordinates are correlated with the help of the equation given here. Vi prime summation j varies from 1 to n aij vj. Here I also varies from 1 to n. And aij is the cosine of angle between xi prime and xj. I have explained it earlier. A11, that will be the cosine of angle between x1 prime and x1. 12, a12, that will be the cosine of angle between x1 prime and x2, and so on. Often the upper limit is n, and corresponding range of I will not be indicated, that may be up to infinity. It is taken for granted that you know how many dimension your space has. If it is 4 dimension, the value of I will be 1, 2, 3, 4. If it is 10 dimension, it will varies from 1 to 10, and so on. Now for the definition of direction cosine, we have also um, shown it that the direction cosine is the cosine of angle between positive xi prime direction and positive xj direction. We may write it in Cartesian coordinate system, that is aij, partial xi prime over partial xj. Using the inverse rotation, if you use the inverse rotation here, the phi, the system of coordinate is rotated in negative direction, means phi is replaced by minus phi. Then the prime coordinate will be on in denominator. Then it will become xj equals summation I varies 1 to 2 aij xj, aij xi prime. Now prime is on right hand side, unprime coordinate is on left hand side, and the direction cosine will be rotated aij is equal to x partial xj over partial xi. Note that these partial derivatives, by using equations, you have seen these equations in our book, equation number 1.16, 1.16a and 1.16b and 1.15. these all these equations, अभी जो हमने equations, मैंने पहले अभी दो equations आपको बताई हैं, उन्हीं equations के बारे में कह रहा है कि जिसमें x prime y prime निकाला था, that now in term of direction cosines partial derivative, in term of partial derivative, they will become vi prime is equal to summation I varies from 1 to n partial xi prime or partial xj vj. This is the old story of vector. If any physical quantity which follow this law of transformation is known as vector, which does not follow this transformation law, that is known as scalar. I mean, if vi prime becomes equals to vj, where I and j are arbitrary, then it is invariant under the rotation of system of coordinate, or you can say that these do not depend upon orientation of coordinate system. If this is so, then it will form scalar. If it any physical quantity, any law that follows this transformation law, that is known as vector. Now these direction cosines, when we know that there are two property of direction cosines. One was uh, these are denoted by lmn, l square, m square, n square is equal to 1, lm plus mn plus nl is equal to 0. That means that when these two direction cosines are multiplied, similar direction cosines are multiplied and added, the answer is always 1. If different direction cosines are multiplied and added, the answer will be 0. This property is given in chronicle delta. Chronicle delta, delta jk is equal to 1 for all j is equal to k, 0 for all j does not equal to k. Therefore, these two property can be combined together and can be written in term of chronicle delta. Summation AJI, AKI, these are two direction cosines and are multiplied where I varies from 1 to n. That will be equal to delta jk. Means k will be equal to chronicle delta. This is the well-known identity and the well-known quantity which we have already studied. And these direction cosines can be written. It means that whenever two direction cosines are multiplied, they can be replaced by a chronicle. That